Welcome once again to my YouTube channel Knowledge Entertainment, and we are once again here with more tricky and difficult questions on trigonometrical identities. And as promised in the previous video, I am going to give you some questions as assignment at the end of this video. If you face problems in solving those questions, those identities, then you can contact me on my WhatsApp number 9041404543. If you will ask the proof of these identities, these problems which I am going to give you as assignment, I will make another video for the solution of those questions in the assignment. But before that, before giving you assignment, I am going to solve some more questions, some more tricky questions on trigonometry. And first question of the day is statement of the question first. Question is, if tan theta plus sin theta is equal to m, comma, tan theta minus sin theta is equal to n, then show that m square minus n square is equal to 4 square root of mn. This is the statement of the question we are going to solve today as the first question. So let us have a look on the solution now. As in most of the cases, we start the question with the left hand side and we arrive at the right hand side. So similarly, I am going to do it here. I am going to solve this problem like this. I'll start with the left hand side. Left hand side, the question is m square minus n square. Value of m is given to be tan theta plus sin theta, and value of n is given to be tan theta minus sin theta. So substituting the values of m and n over here, we will get tan theta plus sin theta square minus tan theta minus sin theta square. Now it is looking like a plus b square minus a minus b square, and we know very well that a plus b square minus a minus b square is equal to 4ab. So this term will be equal to 4 tan theta sin theta. Now I can write it as 4 square root of tan square theta sin square theta, and it is the key step. It is the key step in solution of this question. And now write it is as tan square theta, and this sin square theta I am going to write it like 1 minus cos square theta, and open the bracket. So it is 4 square root of tan square theta into 1 is tan square theta minus tan square theta into cos square theta. When you write this tan square theta as sin square theta over cos square theta, the cos square theta term will be cancelled out and you will left with sin square theta. And now very easily you can factorize this tan square theta minus sin square theta, that means a square minus b square, as a plus b, a minus b. So it is tan theta plus sin theta into tan theta minus sin theta, and now it is 4 square root of this tan theta plus sin theta is given to be m, and this tan theta minus sin theta is given to be n. So it is 4 under root mn, which is the required right hand side of the question. So this was the first question of the day, and It was involving a trick that tan theta sin theta is to be written as the square root of tan square theta into sin square theta. And this was the main trick. This was the key point in solving this problem. And now we'll move on to the second question of the day. It is also a little bit tricky problem, you can say. The question is, if 3 sin square A plus 2 sin square B is equal to 1 and 3 sin 2A minus 2 sin 2B is equal to 0, then find the value of A plus 2B. This is our question, and now how to solve it. So we are going to start the solution now. The first identity given to us is 3 sin square A plus 2 sin square B is equal to 1, which I can write it as 3 sin square A is equal to 1 minus 2 sin square B by taking this 2 sin square B to the right hand side. And now this 1 minus 2 sin square B is the formula for cos 2B. So your cos 2B is coming out to be equal to 3 sin square A. This is the first key point. And from the second equation, 3 sin 2A minus 2 sin 2B is equal to 0. Take this 2 sin 2B to the other side and divide both sides by 2 to find this value of sin 2B. So this sin 2B will be equal to 3 upon 2 sin 2A. So we have solved the key point, and now what we required is A plus 2. So I am having the values of 3 sin 2A, this cos 2B. So having the values of cos 2B and sin 2A, I am going to solve it for cos A plus 2B. Now cos A plus 2B is cos A cos 2B minus sin A sin 2B. And I'll try to eliminate the angle B now. So what I'll get? This is cos A and this cos 2B is equal to 3 sin square A, 3 sin square A minus, here I am having sin A sin 2B, so sin A I am writing it as it is, and sin 2B I am going to replace it by 3 by 2 sin 2A. Now it is 3 cos A sin square A minus this sin 2A, you can write it as 2 sin A cos A. When you will write it as 2 sin A cos A, 2 will be cancelled out with the denominator and you will left with 3 sin A cos A, and 1 sin A is there. So it is 3 sin square A cos A. So it is 3 sin square A cos A. So what you are getting here, 3 sin square A cos A minus 3 sin square A cos A. So these two terms are going to be cancelled and you are going to get it as 0. Now cos of A plus 2B is 0. And we know that 0 is the value of cos pi by 2. So cos A plus 2B is equal to cos pi by 2. And it implies that the angle A plus 2B is equal to pi by 2, which is the required value of the angle A plus 2B. So it was the second point. The key point was to eliminate the angle B in this question. So different questions, different key points, different ideas, different tricks. and different solutions. The specialty of trigonometry. And the next question which I am going to take today is, if sine theta minus x is m, cos theta minus y is n, find the value of cos x minus y. As comparison to the previous questions, it is a little bit easy. Why? Let us have a look at the solution. You are given sine theta minus x is equal to m. From here, you can say cos theta minus x is equal to square root of 1 minus sine square theta minus x. That means square root of 1 minus m square. Similarly, cos theta minus y is n. From here, you can deduce sine theta minus y is equal to square root of 1 minus cos square theta minus y. So it is square root of 1 minus n square. So we were given the values of sine theta minus x and cos theta minus y, and now we are also having the values of cos theta minus x and sine theta minus y. What we have to obtain is cos x minus y. Cos x minus y, I can write it as cos theta minus y minus theta minus x. If you open the bracket, theta will be cancelled and you will get x minus y. Now it is cos a minus b. So cos a minus b is cos a cos b plus sin a sin b. So it is cos a, that means theta minus y, into cos b, that means theta minus x, plus sin a, that means theta minus y, and sin b, that means theta minus x. And all the core values now you know. Cos theta minus y is your n, so it is n, and cos theta minus x you have obtained as square root of 1 minus m square, so it is under root 1 minus m square. Then this plus sign, sin theta minus y is under root 1 minus n square, so it is under root 1 minus n square, and sin theta minus x is given to be equal to m, so it is into m. So this is the value of cos x minus y, which is n under root 1 minus n square and plus m under root 1 minus n square. So it was comparatively easy question, but the trick was involved. You will have to write x minus y as theta minus y minus theta minus x, and this was the trick involved in this question. Next question, I can say, is a little bit more tricky. The question is, show that 1 upon 3 is less than or equal to secant square theta minus tan theta over secant square theta plus tan theta is less than or equal to 3. That means we are actually to find the minimum and maximum values of this expression. So how to solve it is again some tricky solution this question is involving. This term whose maximum and minimum values we are to find, I am going to put it as y. So let y be equal to secant square theta minus tan theta over secant square theta plus tan theta. That means now we are to find the minimum and maximum values of y. Take this denominator to the left hand side, multiply by y, and break this secant square theta into 1 plus tan square theta. What you are going to get now is y into 1 plus tan square theta. This secant square theta I have written like this, plus y into tan theta is equal to, on the right side you will get this secant square theta as 1 plus tan square theta and this minus tan theta. Open the brackets on the left hand side and collect all the terms on left hand side and compose it like a quadratic equation in tan theta. So what you will get, this term will be there, y tan square theta, and this is tan square theta, so you will get y minus 1 tan square theta. Then terms containing tan theta. This is your y tan theta and this is minus tan theta, and when it will come to the left hand side it will become plus tan theta, so you will get plus y plus 1 tan theta. And there are terms not containing tan theta, and these terms are y from here, and this one coming to the left hand side will become minus 1, so it is y minus 1 is equal to 0. So it is a quadratic equation in tan theta. And we know that tan theta is real, it cannot be complex, it cannot be imaginary. So if the roots of this equations are real, then the discriminant should be greater than or equal to 0. So what we are going to have the key point now in this question, since tan theta is real, that means roots of this equations are real, therefore discriminant of this equation should be greater than or equal to 0. And what is the discriminant is this b square y plus 1 whole square minus 4ac, 4 a is y minus 1, c is also y minus 1, so it is y minus 1 square, and it should be greater than or equal to 0. Now simplify it. Simplifying means y square plus 2y plus 1 minus 4y square plus 8y minus 4 should be greater than or equal to 0. Collecting the terms, this y square minus 4y square is minus 3y square, 2y plus 8y is plus 10y, this 1 minus 4 is minus 3 is greater than or equal to 0, and multiply this inequality both sides by minus 1 to get 3y square minus 10y plus 3, and since you have multiplied by a negative number, the sign of inequality is going to change, you will get it less than or equal to 0. Now left hand side can be easily factorized, and the factors are 3y minus 1, y minus 3 is less than or equal to 0. Multiply the first factor by 1 by 3, and since 1 by 3 is a positive number, the sign of inequality is not going to change. You will get y minus 1 by 3 into y minus 3 is less than or equal to 0. And in a previous video we have discussed that if x minus a, x minus b is less than or equal to 0, then x lies in the closed interval AB, where a is less than b. So here y must lie between 1 by 3 and 3, and since equality sign is there, so equality will also be there. So this means 1 by 3 is less than or equal to y is less than or equal to 3. And what is your y? Your y is here secant square theta minus tan theta upon secant square theta plus tan theta. Substituting the value of y here, you will find the result to be obtained. So it was another tricky question from trigonometry, and we are having more questions today. After solving one or two more questions, I am going to give you assignment to solve, and if you are able to solve, then it means you have learned a lot about trigonometric identities. And if you are unable to solve, don't worry, the questions are tricky. You can ask me on my WhatsApp number. I'll give you again. I have given you in the starting as well. The next question I'm going to take is, if a sin theta plus b cos theta is equal to c, then show that a cos theta minus b sin theta is equal to square root of a square plus b square minus c square. So consider this question, maybe the last question of trigonometric identities, and then I will give you the assignment. But first let us see the solution of this question. What we are given with is a sin theta plus b cos theta is equal to c. Squaring both sides, we will get a square sin square theta plus b square cos square theta is equal to c square. And now the key point of this question. Write this sin square theta as 1 minus cos square theta and this cos square theta as 1 minus sin square theta. And sorry, here one term was more, 2ab sin theta cos theta is equal to c square. Sorry for that. Now I'm going to change this sin square theta as 1 minus cos square theta and this cos square theta as 1 minus sin square theta to obtain a square 1 minus cos square theta plus b square 1 minus sin square theta plus 2ab sin theta cos theta is equal to c square. Now open the brackets on the left hand side. A square minus a square cos square theta plus b square minus b square sin square theta plus 2ab sin theta cos theta is equal to c square. Now multiply both sides by minus 1 and take these two terms to right hand side. So when you will multiply it by minus 1, this term will become a square cos square theta. This term will become plus b square sin square theta. This term will become minus 2ab sin theta cos theta is equal to, this term will be minus a square and taking it to the right hand side it will become a square. Similarly this minus b square will become plus b square and this c square will become minus c square as we have multiplied both sides by minus 1. Now this left hand side, you look at carefully, it is a cos theta minus b sin theta whole square and it is equal to a square plus b square minus c square. Taking square root both sides, you will get this a cos theta minus b sin theta will be square root of a square plus b square minus c square. So this was the last question, you can say, of trigonometrical identities. And now the time for the assignment. I am going to give you assignment, and on the top of the assignment I am going to write my WhatsApp number first, so that if you get any problem you can contact me on this WhatsApp number through WhatsApp for the solution of these problems. So assignment's first question is, if a tan x plus cot x is equal to 1, comma, sin x plus cos x is equal to b, find the value of b square minus 2a. This is the first question. Second question of the assignment is, find least value of 4 secant square x plus 9 cosecant square x. You have to find the least value of this expression. The next question for your assignment, the third question is, show that cot x divided by cot x minus cot 3x plus tan x divided by tan x minus tan 3x is equal to 1. And the most tricky question for the assignment is the last question. If sin raised to the power 4x divided by a plus cos raised to the power 4x divided by b is equal to 1 upon a plus b, then show that sin raised to the power 8x divided by a cube plus cos raised to the power 8x divided by b cube is equal to 1 upon a plus b whole cube. And in the next video, now we will move towards the solution of trigonometric equations. And before ending this video here, I would like to thank you, and I hope you that you will like my videos, you will share it with your friends, especially with students of 10+1 non-medical or having mathematics as a subject in arts. And I would like to thank you for subscribing my channel. Thank you once again. We'll meet in the next video.